Hello friends, in this video we are going to learn about data frame and pivot tables. So let's start without any further delay. I have written some key features of data frame. So data frames in Python are two-dimensional structures which are organized in rows and columns like a table and a spreadsheet. They also have labels row-wise as well as column-wise so that data access is easy in them. They can have heterogeneous data, means there can be different types of data in different columns or different rows. For example, there can be a CSV file which have different columns with different type of data like float, integer, string, boolean, or whatever there is. And rows and columns can be added, removed, or modified after the creation of a data frame. They have a tabular alignment, like they are aligned by index and column labels during operations. They also support all the missing operations, finding missing values, finding out which data is none, or removing the missing values, everything. They have other powerful data operations as well, like grouping, aggregations, merging, joining, and filtering as well. They also support vectorized operations, like operations are applied column-wise as well as row-wise efficiently. So this data frame is also built on NumPy, so it has all the performance capabilities of NumPy as well. They have rich input-output support, like every type of file you can access through them, like CSV, Excel, SQL databases, JSON, etc., etc. They also provide the functionality of indexing and slicing, like you can just access data based on label based, position based, or by Boolean indexing. We'll see that in the demo. So in this I'm creating a small data frame using a dictionary. So I've created a small dictionary with name, age, and city, and I'm just calling the data frame function of the Python. So as you can see, as the result, I'm just creating a data frame, and it's in tabular format. So it has taken the labels, it has taken the keys as column names and data as in rows. And you can also see the rows has also default indexes 0, 1, 2. You can also create data frames from different data structures. Like if you want to use list of list to create a data frame, you can do it like this. But here you have to provide your own column names, because in data frame the column name was taken from the key names, but in this kind of scenario there is no key names present, right? So you have to provide your own column names, and it will just make the data frame accordingly. So as you can see, it's the same data frame, only the input that is being passed is different. Similarly, you can pass the list of dictionaries. So here again it will just take the column names from the keys of the dictionary. So as you can see, name, age, and city, it's same for all the dictionaries, right? All the dictionaries that are present in the list. So it just aggregates them as a column name. Now you can also create data frames using a NumPy array. Here you have to pass again the column names here, and it will just create the data frame accordingly. Also, you can just create a data frame using a CSV file. So if you want to read a CSV file or an Excel file, you just need to pass the CSV file in this read CSV function provided by the Python, and it will just return you a data frame that contains all the data of that CSV. So I've just created a small CSV which contains this name, age, city, and salary for different persons, and it has only a small number of records. It has only 4 rows, but it can read the huge number of files as well. So accessing a column can be done by the column name. So I'm just taking an example of this data frame only. Here we have different columns, right? So if you want to access a column, you can just pass that column name, or you can pass the array of column names in the data frame, and it will just give you the access to those columns only. So as you can see, if I run it again, okay, I've not run this one. Let's run it, and after that let's run it again. Yeah. So as you can see, when I am passing the name only, so instead of passing the name as a string, you can also reference it using the dot operator like this. So both of them will give you the same result. As you can see, the result is exactly same in both the ways. Also, you can select multiple columns. In case of multiple columns, you will get a small subset of data frame like this. Now let's see, you can also access the value using the position based index, like using this ilog function provided by the Python. So here it's the same as we have seen in tuples and everywhere. So you can just pass a position. So if you want to access the first row, you will just pass the index of that particular row, or if you want to access a particular row, you can pass the index of that particular row or a subset of rows. For example, if you want the first 3 rows, then you can do it something like this. Similarly, if you want to access a subset like a row as well as column, so you can provide a subset as well. So here it says I want a row 1 and column 2, so it will just give you the value of row 1 and column 2. So as you can see in the original data frame, in row 1 and column 2, the value is Mumbai, right? It will just jump to the column 2, which is city. So as you can see in the output, Mumbai is getting printed, and in these values, as you can see, only the first row is coming. So it just tells you the data of the first row. So it will just give you the data of the first row, which is the data of Amit. So as you can see, along with the column names, it's just giving you the data of the first row, and here it's giving you a subset of the row. So it's giving you all the 3 rows along with the columns and indexes. Now you can also use this log method to access the data frame using labels. So here it also accepts integer. It will just give you the row of a particular row. So as you can see, it's similar to this ilog. I'm getting the first row along with the column names and the data of that first row. Also, you can also provide get the specific value, like you can just say in the first row I want the name. It will just give you the name, like we are doing here, right? And we are just providing the position here instead of the name of the column, right? We are just providing the column 2, which is city column, right? Here you can just provide the name, provide the column name itself. So it will just give you the value from that particular column. So here what I am saying, I want the first I want the rows from 0 to 2, and I just want the name and age of those particular rows. So I'm getting the first 3 rows here. If I see, I'm getting only first 3 rows, 0, 1, 2. Also I'm only getting the name and age of these 3 rows, right? So that is what I am printing here. Where is that? Here. So here one difference is there, like here if you see, if you pass this kind of format, the 3 is not included in the output, right? But in this case, the higher limit is also included in the output. As you can see, all the 3 rows are coming from 0, 1, 2. So this is the small difference between log and ilog. Now we can obviously use filtering operations like we have seen before in NumPy and everywhere. So you don't need to filter using loops or something like that. You can just pass the conditions inside the data frame as well. So here I am saying give me all the age column where the age is greater than 26. So let's run it again. So here you can see all the rows that have age greater than 26 are getting printed. So it will just give you all the info where the age is greater than 26. Similarly, you can pass multiple conditions like age is greater than 26 and city should be Delhi. So in this case, let me run it again. And let's make it scrollable element here. So here in this case, I don't think there is any value like that. So we are getting an empty data frame. Similarly, using getting a single value, so there is a method property called at. So it will just give you the city that is present at first row, which should be Delhi. Let's check the original data frame again. So yeah, so city at the first row is Delhi, right? So if I go back, so it's just giving me the output as Delhi. Also, this is again a different format to access a particular value. Here instead of label you can just give the index. So there is a I present in the method, right? So here you can just provide the indexes as well. Although the result will be same, here you can use labels, but here it will just accept the indexes. So as you can see, only a single value is getting printed again. Now if you want to select rows and column names together, you can again use this log, right? We have seen it above as well, right? So here we are saying we just print us the name of every column. So here we are getting the names. So this is the output for that. And then we are saying we just want the first 2 columns, and we want all all the rows. So here we can see, as we are using ilog and not the log, here the second column is not included. So here name and age are getting printed along with all the rows. Similarly, for log, we are here saying we want the rows from index 1 to index 3, and we just want columns of name and city. So as you can see, first 2 3 these 3 rows are getting printed, and only the name and city is getting printed for these 3 rows. So there are different ways to access the data frame or the value from data frames, and you can use the direct filtering here. You don't need to use any loop or something like that. So you can just do it like this as well, df.query, and you can just pass your condition as a string, where age is greater than 25 and salary is greater than this. It will just give you the result accordingly. You can also do something like this using the query method of data frame. Now I've just created another data frame, so let's create it. Let me run it again, and these are the attributes of a data frame. So it just this demo just shows you the attributes of a data frame. So it just shows you the shape. So here I've created a data frame with 4 by 4. So there are 4 rows and 4 columns. So that's what it's showing here. It shows you the column names as well. So you can just check the column names using this columns. It will give you all the column names. Then you can just check the indexes, how the indexes are looking into, and data types. What is the data type for each column? So age is integer, city is object, salary is integer again. And then you can check the size. So size is like the total values present in a data frame. So I have 16 values, right? 4 cross 4. So total values present in the data frame. Then there are some standard functions provided by Python for data frame as well, like describe, count, sum, mean, max, mode, median. So these are like general functions that we have seen before in NumPy and other libraries as well. It gives you the same. So describes give you all these descriptions about the data frame, like so it just gives you the count, mean, standard, min, and all those things for the integer columns of a data frame. So my data frame here has 2 integer columns, right? Age and salary. Other 2 are string, right? So min, minimum, and average, and all those things applies only to integer columns, right? So it's only giving you for integer age and salary. So describes give you the count, mean, standard deviation, minimum 25%, and all this info in one go about those numerical columns. And if you want it in a separate way, then you can also get it using this count. So here count will give you here count will give you the non-null values for a particular column. So name has 4 values, age has 4 values, so all of them has 4 values, right? So the result is same for each column. But if in case it's a different, if there is any null value, this count will be different, because count only gives you non-null values per column. Then there is sum, numeric only true, because we want the sum on numeric. There is not possible, we cannot sum the string values, right? So this flag just gives you the sum of numerical values. So here as you can see, I'm getting the sum of age and salary. Let me scroll up. I'm getting the sum of age and salary. In similar function, we are getting the mean, median, mode, min, max of age and salary as well. So these are all the outputs for different functions I am using. So this is sum, then this is mean, then median, and then mode, and all those things, min, max, everything we are getting for the numerical columns. After that, an unique is a method that gives you number of unique values per column. So let's say if your column has a duplicate value, then an unique will give you the number of unique values. It's different than count, because count just omits the non-null values like nan and all those things. But an unique will give you the number of unique values that are present in a column. For example, let's say in the data frame, let's say there are 2 Amit. So instead of count as 4 in case of name column, there will be count will be 3, because Amit is duplicated in case of name, right? So it will just give you the count of all the unique values. Then there is this method called value count. So here if you select a column and do a value count, it will just give you the frequency of unique values in a series method. So it will just give you, like Delhi is there once, Mumbai is 1, Bangalore is 1. So it will just give you how many uh, count for each value is present. So for example, let me modify my data frame like this. Let's do Amit here, and then let's do delete twice. Let me create it again, and now run these functions again. Okay, so if you see, let me make it scrollable element. Now if you see, as you can see, name count is 3 here, because now unique name present in the data frame is 3 only, right? So and unique gives you the number of unique values present, and count give you how many values for each value type is present. So Delhi is present twice, Mumbai is present once, and Bangalore is present once. So this is the difference between these two. Then handling of missing data. So let's say I've created another data frame where I have some missing values like none, nan, or all those things. Let's see how. So there are some standard functions like other libraries as well, like is null, is na. It will just give you a true false value whether the value is null or nan in a particular place. So as you can see, the whole data frame is getting printed. Only the result is if the value is null or not. So as you can see, the first value is not a null value, so it's false. But in case of name, the last value is none, it's a null value, right? So the result is true. So it just gives you at the particular place if the value is null or none. Then if you want to drop the null values, you can do it something like this: drop rows with missing values. Here it will just drop the rows which have missing values. So in our case, I think there are there are 2 rows with missing values. Let me check. It's printing only 2. I think so. There are more than 2 rows and are missing values. We have total 5 rows. So we have 1 row, second row, and third row. I think this one as well. So we have 3 rows which have missing values. It will just drop all the complete row which has missing value in any of the columns. So as you can see, only 2 rows are getting printed because all the other 3 rows have missing values somewhere in one of the column, right? Now if you reverse it, like provide a parameter called x is equal to 1, it will just drop all the columns which have missing values. I think all the columns have missing values in our case somewhere. So that is why we are getting an empty data frame. And then there is a drop na also. In this case, if you there is a how parameter which tells you how you want to remove your rows. So in this case, if you want to see like drop my row if all the values in a row are missing, right? So that row is like not usable at all, right? So you can just provide all. In this case, it will only remove the rows if all the values of a row have missing values. So let's check the output of the last. So in our case, there is not a single row which has all the values as null. So we are getting the whole data frame as it is. So as you can see, in this one with the access value as 1, we are getting an empty data frame because every column has a null value somewhere. So here it is null, and here it is null, then here it is, and there it is. So that is why we are getting an empty data frame here in case of x is equal to 1. Now let's move to other operations. So we have the same data frame again, and we want to fill the null or none values with something, right? Then we can do something like this. So if you want to fill with the constant value, like we want to fill all the missing values or null values with some constant value, you can do something like this. Here everywhere, whether it's an integer column or a string column, it will just put that value as default. So as you can see, all my null values are filled with 0 0. Then you want to do something else, like you want to fill numerical columns with mean in case of missing values. Then you can do something like this. You can just say in case of age, just fill the missing values with mean, and in place true means it will just replace the values in the original data frame. Or you can in case of city, like city is not a numerical column, right? So mean and max, all those things will not work here. In that case, you want to city to fill with mode, like whatever city is occurring most, you want to fill it with that. So you can do something like this: fill it with the mode value, which is whatever city is occurring most. It will just replace the null values in city column with that particular value. Then so there is a method called interpolate as well. So let's make it a scrollable element again. So interpolates, it checks the surrounding data rather than the simply dropping or copying the values. So like here we are either dropping the values, like here we were simply dropping the null values, right? And here were simply replacing the values using mean or mode or like whatever value we want, or a specific value we want, right? But in case of interpolate, it checks the surrounding data, like it decides the value according to the data that is present in the surrounding rows, and it fills accordingly. So if you want to see the output of that particular thing, let's say we have this data frame like with day and sales. So here we have day 1 2 3 4, and we have sales as 100, then we have two null values, then 400. So if we run an interpolate on that, it will just check that the initially sales were 100, then 400. So it's a in this case it's a linear interpolation. In this case it will just fill this gap with 200, then this with 300. So if you see the output here, as you can see, we are getting 100, 200, 300 and 400 as the final output after interpolation. So it's a linear interpolation. You can have multiple types of interpolation, but in this interpolation case it just checks how the data is looking and where the data is present, and accordingly it fills the values in the missing places. Then we have merging and joining operations in data frame as well. So let's say we have an employees data frame and we have a department data frame. So here employees data frame has the employees info like name, age and department ID, and then department data frame along with the department ID has the department name. So let's say we want to merge them like in SQL tables and all those things, right? We want to merge these two data frames according to the department, right? So we can just join them like using a department ID. So we can do all types of join, like inner, left, right and outer join, like we have in SQL, right? We have different types of joins. The same we have in here in the data frame as well. So in case of inner join, it will just take the department ID from both the columns and match one by one. Whoever gets matched, it will be printed in the final data frame. So we got 3 matches for Amit, Riya and John. For Neha, department ID is 103, which is not present in the department data frame, right? So it's not getting printed. But in case of left and right join, whoever in case of left join, if the first table does not have a match, only that part will be printed, but the value of the second table will not be printed. So here, as you can see, the Neha is also coming with department name as an N. In case of right, as you can see, Neha is not coming, but we have a department in this data frame 104, which is not present in employees data frame, right? So this is coming because the missing entries from this, in case of right join, missing entries which are not getting matched from this data frame will come, but not from the first data frame. And outer join is the combination of these two joins, right? So we will get entries from both the tables. So if I make it a scrollable table, as you can see, we have Neha as well and we have department 104 as well. Then we also, if you want, if you have different column names, so here the column name is same for both the data frames, right? But if you have different column names for employees and departments, like here it's instead of department ID, let's say here it is department ID, but instead of department ID in the department data frame, here just ID. Then you can use something like this, like left table has department ID as a column name and right table has ID as a column name, and it will just perform join operations based on these two columns. The result will be same as this one, inner join. Yeah, now you can also join using index base. So if you want one of your column to become an index after joining it, so you can do something like this. So you want the department IDs to become as an index in your join, right? So here I'm setting department IDs as index on both employees as well as departments, and then I'm joining them using these indexes. So after setting up the department IDs index, your employee table will look something like this. So this is the result. So here department ID has become the new index now for each row, and you have employee ID and name, and same has happened for the department. Now if you just say the join these two data frames, then it will just take the indexes, and according to the indexes it will give you the joint result. So as you can see here, department ID is again the index for each row, and we have 3 columns: employee ID, name and department name. Here we are getting Neha because initially it's taking the left join because we have provided the employee index first, and here it will just take the left join by default. And as you can see, department IDs has become the index in the new join table, and all the other information is kept in the columns. Yeah, now we have concatenation method as well in DataFrame, where you can just concatenate the rows of one data frame with another. So here I'm just concatenating the department data frame with employees data frame, right? So it will just take all the data from departments data frame and put it in employees data frame. So as you can see here, it's not joining like we have seen here, like using the department ID to check the matched values and showing the result. It will just take all the rows from department column, department data frame, and put it in the employees data frame. So here as you can see, we are getting all the info. First 4 rows are from employees and the next 3 rows are from department. So it's adding columns whatever is required. So department ID is same in both, right? So it's coming once, but department name is getting added. And for the first 4 rows it has nan as value, and the last 3 values are coming from department's data frame. So if you want to concatenate using column wise, so you can just provide the axis as 1, and again it will just give you a new data frame with concatenated data as column based. So here as you see, whatever is matched, so Amit belongs to department HR, right? So as you can see, it's matching according to the sorry, it doesn't match, it just goes by row. So in my department data frame, if I go to my original data frame here, my first row is HR, then IT, then finance. It will just take the first row and it will just add it to the first row of employees, second row to the second row of employees, and so on. So here as you can see, let's go back. Here as you can see, this department ID is matched by luck, but here as you can see, we have 2 department IDs because third row here is finance and departments data frame, and third row has John as a row, John in the employees data frame. So it just concatenates row wise, takes the first row, put it in the first row of employees, and so on. And since we do not have a 4th row in department data frame, it's nan here. Now this is another thing. I'm just creating a small data frame with student ID, name, and the scores of different students in different subjects like math, physics, and chemistry, for which I'm just adding some random values for 10 rows. So we have a total 10 rows for 10 students, and for each row I'm just adding some random value from 50 to 100 and 40 to 100 and 45 to 100. So let's first take a look at the original data frame. So this is our original data frame. Just number of scores the students have scored in different subjects randomly. Now this is just a demo of performing different operations in a particular data frame in real-time scenario. So let's say we want to add a total column. So initially we have math, physics, and chemistry. We don't have a total, right? So we want to add a total column in our data frame and an average column as well. So here we are just saying just create a total column while summing up the results of all these 3 columns, and then after we just want to add an average column while doing this operation, like whatever the total is divided by 3 and add an average column. So now if we see a data frame after adding total and average, you can see there is a total as well as an average column present in the new output. So initially the data frame was like this, but now we have a total as well as average column as well. Let's make this scrollable. Yeah. Now after that, let's go to the top. Yeah. Now we want some filtering rows, like we want students with average greater than 70, right? So we already have average column now. So here we are just saying give us all the students whose average is greater than or equal to 70. Or we want some multiple conditions, like with math greater than 80 and physics greater than 70. So we can do something like that as well. Just as we have seen above, we can just filter out students whose math score is greater than 80 and physics greater than 70. So if you go look into the output again, so students with average 70, here are all the students whose average is greater than 70, and here are all the students whose math is greater than 80 and physics greater than 70. We have only one in that case. Okay. Then you can do something like this as well. You can also sort your data frames according to some column you want. So you want to sort your data frame according to the average and in ascending order. So if I go back to the output again, after sorting average in descending order, you can see it's sorted in descending order as per average. So the student with the highest average is on the top and the student with the lowest average is on the bottom. So you can also perform sorting on different columns in a data frame. You can also pass multiple columns if you want, like we have done in SQL, right? Also grouping and aggregations, right? So let's say I've created a function grade. So we want to provide grades according to the scores of a student, right? So here we have put conditions like if the average score is greater than 85, then grade A. For greater than equal to 70, we are assigning grade B. For greater than equal to 50, we are assigning grade C, and then for rest grade D. So here we are creating a new column and we want to apply this function while calculating the grades of a particular student, right? So we can just say on average column you have to apply this particular function that we have written and store the result that is getting returned from this function as a grade column. So now if you will see this data frame after we have applied this function, let's see. So here as you can see, a new column grade has been added, and according to the average that is present here, the grades had been assigned to all the students. So you don't need to pass all the logic inside these square brackets only. You can just create your own functions as well, and you can just apply those functions while creating a new column like this. Okay, the next is now we want to average total per grade. So you can also do group by, like you want to group by according to the grades of different students, and you want to get the average score according to that, and like whatever students that belong to grade B, what is the total of that or something like that, right? If you want to group by your result according to some column and perform operations on that, you can also do that. So let's check it here again. So here we are grouping in our case we have only two types of grade, right? B and C. So as you can see, our total is the whole data frame is grouped according to the B and C, and we are just getting the total of average for each grade. So B grade, if you we are doing it on average column, right? Let me check. We are doing it on total column, not average column. So we are grouping by grade and then we are calculating the mean on total. So we are grouping by B and then we are getting the mean of this total. So whatever B columns, B rows are there, it just sums up the total and get the mean of that, which is 233, and same for C grade. So that's how you can perform the group by operations as well on data frame. Now we have created another data frame with the student ID and the city information for some students in that. So we have information of city for these 5 students, and we already have a student ID column in our original data frame, right? So here we are merging the city information with the original data frame. So this is our original data frame, this is our extra info, city info, and we are doing a join on the student ID and the left join, because we want all the student information, and whatever city information is present in this, we will just want that. So this is just the left join as we have seen above. So if I now show you the output of this, yeah, as you can see, the last 5 rows are coming as none, and only the first 5 rows are getting filled according to the cities those students belong to. So this is TF merge data frame with city. I'm showing you the correct output, right? Yeah, here it is. This one is the correct one. So yeah, so this is the same output. These two rows are the same output, as because of space the city column is going below. So as you can see, all the information from the first data frame is coming, and the city for the first 5 students is also coming. Now let's move forward. After this, now we want to save this result in a CSV, right? So we can use this toCSV function provided by the Pandas library. Here we are creating a new file called student.csv, and index is false, and we just We are just creating this data frame into the CSV and saving it as a file as student.csv. After that, the file is getting created. If you see, student.csv is getting created here in my structure, and after that you can just read the file and load the data frame again. So as you can see, the last data frame which is getting loaded is same as all the operations that we have performed on the data frame, with grade, average, total, and chemistry. Obviously the city is not coming because I had created another data frame called df merged with this city and all, and I am saving the original data frame that was there with average and all. So city is not coming in the CSV. Also, you can perform your visualization using this matplotlib library provided by the Python on the data frame. So here I'm creating two different graphs for scores of math and average, and so I'm just plotting the math and average scores on the graph with different colors, and I'm just providing the label of math and average. So my x label will be math, y label will be average, and I'm just plotting the students according to these scores on the graph. So as you can see on the graph, this is one student whose math score is somewhat around 59 and average is something around 51, I guess. So this is how you can just plot your scores on the graph. You can also create different types of graph, bar graph, or the any other kind of graph you want. So this is how you can perform different operations in a real-time scenario using data frames. Now we have pivot tables. So pivot tables are used for analysis purpose. Like you have your data frame, you can just perform different operations on them, but pivot tables are used to perform different analysis on that data, perform analysis queries on that particular data frame. So this is the standard structure for pivot table. So you have a data frame already present. I've created a data frame with different sales of different products in different cities, and here I'm creating a pivot table where first you have to provide from which data frame you want to create the table. Then you want to tell which column you want to segregate. So here I'm looking into the sales, how many sales how many sales I have done for different products. Then my index is city, in which city, and the column is product. So as you can see, I have Delhi and Mumbai as the city only. So in my output, Delhi as Mumbai is coming as index, and the column is product, so which is laptop and mobile only, right? So I'm getting laptop and mobile as my column in the pivot table. Then how I want to see my sales, I want to just sum up all the sales. I want to sum up all the sales in different cities. So here it gives you in Delhi the laptop sales are 50,000. So as you can see, if you check in Delhi, entry for Delhi and laptop is only one, I guess, this one only, which is 50,000, which is coming here. But if you will see Mumbai laptop, if you see Mumbai laptop, here we have one, and then here we have another. So this output 1 lakh, this is the sum of this last entry and this entry, which is correct, right? So it will just give you the sum of all the it will just give you the sum of all the sales that has been happened for different product in different cities. Obviously you can use different functions here. Like here I'm using multiple aggregate functions. I want sum as well as mean of my sales in different cities as for different products. So it will just give you that I'm getting sum as well as mean of my sales in different cities and product. Then there are different ways to create pivot tables as well. Instead of looking for a particular column as well, you can look for different columns. Like you can just provide multiple column names here. You want to do it for sales as well as profit only, and for sales you want sum and mean, and for profit you want the maximum value that is present for a particular product and city. So here you are getting that. So in case of profit, you are only getting max value of laptop and mobile for different city and product, and in case of sales you are getting mean as well as sum for laptop and mobiles in different cities. Then you want how many so here I'm creating another pivot table where the index is city and index and columns are again same, but my aggregate function is count. So here I'm checking on order ID. So if you will see, my order ID is this, right? So I just want the count, how many orders have been there. So you can just use the order ID for that, right? If you just want the count of the uh, order, then it's giving you that. In Mumbai we have two orders for laptop and one order for mobile, and in Delhi we have one order for laptop and two order for mobile. So you can just change the column that you can use for that purpose and just provide the aggregate function as count. Now you can also create multiple hierarchical pivot tables as well, like sales by city, then product. So here in values we can provide multiple values, right? Similarly, in case of index, which is used for this purpose, you can provide multiple values. Like first you want to look for city, then product. So here, as you can see, first it's looking it's segregating the value using this Delhi, Mumbai city, then product, then it's showing you the profit and sales. So in Delhi for laptop, profit is this and sales is this. So if I remove this margin name column and run it again, I have to run the data frame in the top. So let's run it, and then after that let's run it. To move this. So as you can see, initially it's checking the first it's look into the city, then in each city it looks into the each product, and for each product it will give you the profit and sales. So these margins, it just adds the total of that of the whole total at the bottom. So if I command them again, margins to and margins name total, it will just add another row with the total of all this information in the bottom if you want it. Then there is this, you can just create our own custom functions that can be passed as in the aggregate functions. So if there is something that you cannot fulfill by the already provided function, then you can create your own custom functions for that. So here it's the same. I'm just created my custom function which gives me the range by deleting by subtracting the max by min value, and if I run it again, you can see it's giving me the value according to the custom function I have written. So you can just provide your own functions as well. Okay, this is all for this video. I hope you liked it. Please like, share and subscribe.